The reference frame in which the center of inertia is at rest travels with a velocity v relative to an inertial reference frame k. So let's call this reference frame as k dash, which is moving with velocity v with respect to k. And it's given that in this reference frame, the center of mass is at rest. So let's put the origin of this frame on the center of mass itself. And the energy of the system of particles in k dash is given as E dash. We need to find what is the energy of those particles with respect to reference frame k. So once again, let's read the question. The reference frame in which the center of inertia is at rest translates with a velocity v relative to an inertial reference frame k. So it's traveling with v relative to k. The mass of system of particles equals m, and the total energy of system in the frame of the center of inertia is equal to E dash. So frame of center of inertia is nothing but k dash. So with respect to that, the energy is given as E dash. Find the total energy E of the system in the reference frame k. So in the reference frame of k, what is the energy of the system? So we are given E dash and we need to find E. So let's writing the equation of E dash and then we'll write the equation of E. E dash is equal to, so total energy is potential energy plus kinetic energy. So kinetic energy in reference frame, it's its own reference frame, is equal to P plus half, let's call it Mi Vi dash square, where Vi dash is the velocity of each particle with respect to k dash. So I is just the number of particles. So m1, v1, m2, v2 dash, like that. Now the energy which we need, that is E. So that we can write as Pe plus Ke. Now you can understand here that potential energy of the system is independent of the reference frame. So here if you are writing Pe, here the value of Pe is same. Ke, however, depends on the reference frame, so we'll just write it as Ke. And now Ke we can write as half Mi into velocity of particles in the reference frame of k whole square. So if we just take one particle, so you can imagine that if you have a particle here, so its velocity with respect to k will be velocity of particle with respect to center of mass plus velocity of center of mass with respect to k. So velocity of particle with respect to center of mass will be v dash, and velocity of center of mass with respect to k is v. So that's what we have written, vi dash plus v. So here I have just what I said, I have just written it here. This is velocity of I with respect to center of mass plus velocity of center of mass with respect to k. So I with respect to center of mass is v dash and center of mass with respect to k is v. So I have not written the bars here, but these are basically the magnitudes of vi vector plus v vector. So if it's the square of the magnitude, we can write it as dot product of these two, just writing it twice and doing the dot product of it. Now we will expand this brackets, so what will be left with is Pe plus half Mi Vi dash square plus half Mi V square plus half and half will become 1 Mi into Vi dash dot V dash. So this part is E dash. Half Mi V square, so sigma V square is a constant, so sigma Mi we can write as half mv square. And this term, let's see it separately. So again dot V bar is constant. So we'll take the Mi Vi separately for each, and dot V vector is common for all those particles, so we can write this as this. Now this part, sigma Mi Vi dash, is the momentum of system of particles with respect to its center of mass, and that we know is 0, which means this whole term is 0, which means this term is 0. So what we are left with is only these two terms. So our energy which we need eventually comes to be E dash plus half mv square, which is a very general formula, and we are going to use this in lots of places. So we have derived that kinetic energy with respect to any frame is kinetic energy of particles with respect to center of mass plus half mass, total mass, into velocity of center of mass whole square. So very, very important formula. This is the derivation of it.